Hello and welcome to this short video where I briefly talk about the contents of my bachelor thesis. In this project, I fine-tuned large language models with the task of SysML model generation. So SysML is used in many industries for modeling complex systems, such as cars, and large language models, such as ChatGPT, are shown to have remarkable performance in many tasks, such as translation or code generation. And I thought that having large language models generating SysML models could be very beneficial. For example, system engineers could use these models for creating initial drafts of system models. Or students can use these in order to understand the syntax of SysML by prompting these models and learning from the outputs. For fine-tuning a large language model, one first needs a dataset. I got my dataset from the chair of software engineering at RWTH-Aachen, and this dataset contained pairs of SysMLv2 models and corresponding generation prompts. Here is an example of a SysMLv2 model and its corresponding generation prompt. As you can see, this prompt commands the LLM to create a model of a vehicle with an engine and some other details, and these details are also apparent in the example SysML model. Before doing fine-tuning, I did few-shot learning. That's an approach that doesn't need fine-tuning, and I used it as a baseline. In this approach, one prompts the model with some additional examples. So this prompt could be something like this generation prompt, and I pre-print some examples, and each examples contains a prompt and a corresponding SysML model. I also prepend a header prompt which describes the general task of the LLM. Here is an example of a few-shot prompt. So that's the header prompt explaining the LLM the general task, and that's the example. As you can see, it consists of a prompt and the corresponding SysML model. Here is the actual prompt that we're interested in. Here are the results of few-shot learning. I tested these open source models, so Llama 2, Code Llama, and Llama 3 models. And in this graph, the x-axis corresponds to the number of examples that you prepend to the few-shot prompts. In the y-axis correspond to the parsability of the outputs. So how many of the outputs of the large language were actually parsable. So it describes the performance of the models for the task of SysML model generation. As you can see, only giving one example results in the best performance, and further introducing more examples degrades the performance for most of the models. And notably, the Code Llama models, given one-shot prompts, perform the best, and they can reach a parsability of 68%. After that, I did the fine tuning. So basically, fine tuning refers to training an already trained model further. And in the process of fine tuning, one updates some of the parameters of the large language model based on some data, which in my case was SysML data. So pairs of SysML and prompt data. And I use the QLoRA approach, which is an efficient way to fine-tune large language model that only trains some of the parameters. And furthermore, I fine-tuned these two large languages, so the Code Llama 7B and the Code Llama 34B. These were also among the best models in the few-shot learning experiment. So these are the results of the fine-tuned Code Llama 34B. And these are also the best results that I could achieve with fine tuning. And as you can see, the best results correspond to a parsability percentage of 55.56%. And as you can see, I couldn't outperform few shot learning in this project. But nonetheless, I have some examples from uh, outputs of the large language models before and after fine tuning. Here is an example. As you can see, the large language model before the fine-tuning attempted to describe the model with some graphical notation with underlines and plus signs, But after the fine-tuning, one can see that the model actually produced something very similar to SysML. Unfortunately, this is not a correct output, but we can see the improvement. Another example, we can see that before the fine-tuning, the model described the system model using an XML syntax, but after fine-tuning, we got actually a correct, parsable SysMLv2 model that described these prompt correctly. Here is another example of the unfine-tuned CodeLlama 34B model. You can see that the outputs are better, it's more code-like, but it's still not SysMLv2. After fine-tuning, we get a parsable, correct SysMLv2 model that corresponds to this prompt. So to conclude this video, I showed that LLMs can actually be used to generate SysMLv2 models. And among the Llama model family, which are the go-to open source large language models, the Code Llama are the best language models for this task. And I showed that few-shot learning is a simple but yet powerful approach for SysML model generation. And in this work, it actually outperformed fine-tuning. I put this in parentheses because I couldn't outperform few-shot learning. And the main reason could be that my dataset was too small, so I only had 182 examples. But with more dataset, I think that one could outperform few-shot learning. But nonetheless, few-shot learning is a powerful approach. All right, so that's all. Thank you for your attention.